Guys, welcome to Quotation. Today we are going to talk about data structures. As I said in the last video, data structure is a very important aspect of programming, and we need to know all the different types of data structures that is out there, at least the basic types. And if we can really understand the basic data structures such as arrays, linked lists, graphs, trees, then we can work with the complex kinds as well, since they're mostly derived from the simple ones only. So data structures are different ways of storing the data that you're going to process or work on in the computer. So when you're writing a program, you will be working on some data, processing some data or getting some input and creating on some output. And for storing that input or for storing some intermediate data, you need a data structure. So and for each and every kind of algorithm you need some well-defined data structure that will go with that algorithm. So like I said in the last video also, like all data structure won't go with every algorithm. You need to find the perfect match for every algorithm. So data structures can be broadly divided into two classes. So one is a linear kind and the other is a non-linear data structure. So you can think like linear data structure, the data is arranged in a particular sequence. Like the first, so we have set 10 data elements. I'll be storing the first in certain way, and the second, third, fourth, all of them will be in a particular sequence. Whereas in non-linear, we don't really follow some particular sequence in ways of storing the data. I'll come to non-linear data structure and I will try to draw something out for you guys so that you can easily understand what are the non-linear data structures. But let's start with linear data structure. So let's start with arrays today. So before diving deep into data structure, so we have to understand one thing. So what are these data for which we need this data structures, right? So you all know there are various kind of data out there. So there is, say, integers. So I am not following any particular language regarding this. Maybe you will find some resemblings to C in this case, but I when I will dive deep into coding, I'll mostly use C++ or Python. So they are most, like, in the sense of competitive coding and as well as programming interviews, C++ and Pythons are mostly is mostly used. So basically we have this different kind of data types, right? So there is this integer, then there is this character, there are double, there are long ints. So basically what are these? So these integers are numbers like -1, 2, 3. So these are like numbers like this. So these are numbers like this. So what are characters? Characters are like A, B, C, D, yeah, isn't it? So like A, so it's like B, even this is a character. So one, we are storing in the ASCII format. This is also character. 2, this is a character. So it's just a single byte of character. So I gave it away to you guys. So characters are like single byte length normally. Integers are like 4 byte lengths. Doubles, what are doubles? Doubles are like real numbers. So like you need to store numbers such as 1, 2, 3.4, 1, 2, something like this. So you will store this kind of data in a double. So for a long int, like you need a larger sized integer, say. So basically this integer in this first aspect is normally of 4 bytes, right? So these are for 4 bytes normally. So 4 byte has a specific range of integers which can fit into this 4 bytes. So this is 32 bits length. So for long ints, it's, say, sometimes it's 8 bytes. So you can have a wider range of data. So like for long bytes, for it depends on different kind of languages, but say for one kind of language it's say from -2 to the power something to +2 to the power something. Then for long int it will be like the range will be further like bigger. So like if you want to see it like this, it's like so if this is the real number axis, and so this is the range of, say, integers, then for long int it will be more, the range will be more, nothing else. So it will say from this to this is for the long integers. Okay, so this is the simple differences, and you need to find the perfect data structure for the this kind of data types that you want to store. So yeah, one more thing I want to tell you is regarding the RAM of a computer, how actually you store this data into the computer's memory and stuff like that. So as you know maybe, so this we have this RAM, right? So we play games on this computer. With more RAM you can play better games. This is the basic concept. So yeah, so the thing is like this RAM, so this RAM is addressed like that, like this. So we have this huge sequence of memory elements. So this is a very weird drawing, but say this is the first row, this is the second row. Each row say holds say some 1 byte of data set, and I have say 8 gigabytes of memory. So in this way, if you divide 8 gigabytes by 1 byte, we will have some discrete number left, and that will be the list number of rows. So now when you store some data into it, say you store an integer of 4 bytes, it will take this 4 rows, say we'll take it as an array. You will take this entire thing as one integer. It will store one integer, say one is 12. It will store this 12 in this 4 rows, and 1 row is of 1 byte. So this is just a hypothetical example of what it may be. So in this way it will store different data throughout the RAM, throughout the memory. So yeah, let's get back to our main discussion. So what is an array? So basically arrays are, as I said previously, it's like a linear data structure. So say this is an array of say length some n, or say 10 you presume. So and I have say 10 numbers, integers in this case, that I want to put inside an array. So this is say 1, this is say 2, this is say 3. These are the different integers that I am putting into this array. So in this way there are say 10 numbers. Okay, so the first basic thing is that we start, so this is the indexes, right? This is the first one, second one, third one, and this way is the 10th one. But when it comes to computer science, for some weird reasons, we start our indexing from 0. Okay, so I'll call this as the 0th element, this as the first element, this as the second element, carry on like this, and this as the n minus 1, that is the 9th element in this case. Okay, yeah. So this is basically a structure of an array. So the array or the static array, I may say, is a fixed size when you first begin. Okay, so it's of a fixed size. You cannot once defined. So say you define an array like this. Again, I am not referring to some particular language, but you say you define an array like this. This normally means that the length of the array is 50. Length is 50. So you can store 50 integers into this array. Okay, so it's fine, you can store 50 integers into this array. So what are the benefits of an array, if I may ask? So as you can see, as I told you, in the RAM we are storing this data like sequentially in that form. So this array, as you can see, is a sequence of integers ultimately. So if you know the location in the RAM of this first element, and you know that a one integer is of say size 4 bytes, so it will take 4 rows from that, then you can easily calculate the location of the third element, this second element, this, what I may say, in this case, what is this? Array 2 is equal to 3 in this case, in this array. So basically it's pretty simple, as you can see. So if I know this location of this first element, then I can easily know the location of all the subsequent elements. So in this way we can find any element, like we will be able to index all the elements, and we'll be able to find say the fifth element in a O1 amount of time, like in a constant amount of time. I will describe to you what do I mean by O1 or ON later in some other video, but for now it's said that it's very easy. So like you don't need to search for that element in the array. You can easily find it just by going with the base index. You say this is the base index of the array. You start with the zeroth element and you add on to the size of two integers to it to find the third element. So I'll find that array of 2, that is the third element, is 3 in this case. So yeah, so but arrays are first I must say is very versatile and is used throughout computer science. Like wherever you use, wherever you program, whatever language, whatever thing you want to code, arrays are like very flexible, very robust when it comes to use. But yeah, they do also have some disadvantages. As you can see, like for an array, we cannot increase the size of an array once defined. So like I defined this array say length 50, right? But if I have this 51st element that I want to put inside this array, then we cannot do it, because like I have defined it to be of length 50. So you cannot like dynamically increase the length of the array. So that you can do with an array. Again, say I want to put a number, say this is say 5, this is 4, say, and I say I want to put one number in between this 3 and 4. In this location I want to put one number. That I also cannot do with arrays, because arrays are like, once you define the arrays, once you put in elements, it's like defined. You cannot reorganize the array in so easily. Like you can obviously do it, but it will take up much more time. I'll talk to you regarding what I mean by time again in the time complexity analysis that we'll discuss. So yeah, these are all the disadvantages of an array. But overall, arrays are very useful. They are useful in all kind of algorithms such as sorting, searching, and mostly they are very important in programming interviews, in any job interview, in mostly all the coding. Like since it's very easy and fast to operate on arrays, we tend to use it very much in competitive programming as well. I'll discuss some questions regarding arrays as well in the upcoming videos. And please keep in mind that array is a very important topic in computer science and in programming as well. So yeah, so let's I'll explain to you guys one more data structure so that kind of tries to complements and tries to overcome the problems of an array, but it has its own problems that comes with the data structure. So no data structure is perfect in any sense. For all the different aspects of programming, or for all different kinds of programming, we will be needing different data structures. Okay, so now we will talk about linked lists. So linked list is a very important concept. So I'll introduce to you guys a simple a new concept here. Just bear with me to understand it. It's pretty simple. So this is basically, I'm writing it in C, but yeah, I'll explain to you guys. Don't look into the syntax much. It's nothing. It's very simple. I'm using the word simple a lot here. So yeah, as you can see, in C or in all of the languages, I can custom. So we had the data type integer, right? We had the data type double, we had data type character. So in C we can define our own data types. Okay, so this is a data type that I am defining using this keyword in C. So just forget about it. So this data type is comprised of this data, this integer data, and this pointer. This is a next pointer. So I'll tell you what is a pointer. So pointers are basically very simple. People try to confuse it hell lot, but pointers are very simple. So A, B, C, D are 5 friends. So A has his test marks score, maybe his marks in English maybe, and he has the phone number of say B, so he can contact B. Okay, so this phone number of B will let me contact B, but this resides with A. So basically this is nothing, this is just another so I'll tell you in this simple way. It's just a placeholder in which we keep the address of the next element that we want to access. So I'll tell you what is a linked list in this concept. So basically this list node, it's a single node of a linked list. Okay, so it starts with this, I'll just explain to you guys what I'm doing here. So as you can see, the problems, so you remember the problems of the array, right? So they are not, you cannot insert or delete an element from anywhere in the array in a very easy way. You cannot increase the size of an array once defined. So these are the problems of an array. So in order to solve those problems, we come up with linked lists. So what are these linked lists? So these linked lists are basically linked nodes. So this node I defined here, so it comprises of data. Okay, so say I stored this data, the value is 10, and as you can see, I am storing a pointer that I told you that it contains the address of the next element in the, so this is the pointer, it contains the address of this element. So I put in another number, 12, and I have the address of the next element here. So in this way it grows. So basically it starts with a simple head pointer which points to the first node. Okay, so when you add another element, that node will point to the next node that you add to. So this B node, so this node is newly added, and you add it to the next pointer, and in this way you add another node to it. And the thing is, for the final node, say this node, it has nothing to point to, right? It is the final node, so you point it to a null pointer. So it's just a null pointer, it points to nothing, right? Once a new node comes, you can attach that node to this point. So as you can see, it overcomes a lot of problems of the arrays. So it is evident to you guys that this linked list can grow dynamically. It doesn't need to be given a proper or a certain size to it. It can grow dynamically. You can like bring a new node to it. Say I want to put this, so this is say another node, say this node, say another node, and say 9, and I need to put this 8, this 8 node in between this 17 and 9 nodes. Weird, very weird 17 though. Yeah. So what I'll do, so basically it's very simple. So what can you do is, let's just point this next node to this guy, make the next node of this guy point to this guy, and just simply remove this node. Isn't it? It's just that simple. And you can insert any new node between any two nodes. So as you can see, deletion is also that simple. What do you need to do? You just delete this node. If you want to delete this node, then you just delete this node, and you just establish that previous connection that was there. So it's as simple as that. So insertion, deletion of elements inside the linked list, increasing the size of the linked list, it's very simple in this case, and it overcomes the problems of an array. So is this the final option that we are going through for every kind of data structure, for every kind of programming? No, because as you can see, like it solved that problem, but with an array we used to get that added advantage that we can find any node, say the third element, easily by just indexing to it, because we knew the base address. But in this case, each of these nodes, they are not located contiguously in the memory like that used to happen with array. So we cannot just add the like offset to the base and find the address of the, say, the 4th or the nth node. So for that we have to do a linear search. So we'll start with the head node, head pointer, will then go to the head node, then we'll start with the next node, then next node, then we'll find our element that we want to find. So as you can see, it's it's very hard in case of an in this case, so to identify an element, to properly find an element. So for this reason, it has some various different kind of uses. So the use of arrays are different, the use of linked lists are different, but both of them are very important data structures. So you need to go through each of them. So the next video we will move on to stacks and queues. in the comment section, do post all of your questions that you have regarding linked list arrays. I know the pointer concept in linked list can be very confusing at times. I'll try to explain to you guys in a separate video more simply, so that you can easily understand that part as well, because fundamentally it's that easy. It's very simple. You just need to trust me on that. We will be solving problems on linked list and arrays. Just go through linked list, try to solve a few problems. If you cannot solve a particular problem, post it in the comment section. The entire community will try to help you out, and we will learn with all those questions as well. So thank you for joining me again. So I'll get back to you again with the next video, most probably on stacks and queues. So yeah, thank you. Thanks for being a part of CodeOcean. Please do subscribe, and yeah, thanks for being with me.